Hi and welcome to this video log with me, Wayne from SwimCycleRunCoach. Well, this week is a continuation of last week where we were looking at a new model of efficiency for calculating how far someone goes. The normal model, to remind you, was stroke length times stroke rate equals the distance swum. And I suggested that instead of that we need to look at the efficiency of the arms plus the efficiency of the legs and multiply that by the stroke length and we'll get a good model. This week we're going to start that, and I've been doing some filming to help you do that. So we're going to go to the computer and have a look.
Okay, so here we are looking at Adam. He's a reasonably good swimmer from Hartsmere Flyers. His PB for 100 metres front crawl is 58.4. What we're going to try and do with Adam is check out his stroke length, his stroke rate, his speed of swimming, and effectively work out an efficiency rating for him. So that's what we're going to do. I'm going to record all the figures down on a spreadsheet. I'll show you that as we go along so you can copy it if you're a coach. That hopefully will be helpful to you. The first thing we've done is calibrate this picture to make measurements successful, and what we've got in between these two floats here is a meter rule. Now from that meter rule I can calibrate a measure, and then all lines will be calibrated from that accurate measure. Therefore we should get accurate statistics. That's the theory anyway. The first thing we're going to do is take Adam forward a bit so we can judge his stroke rate. We're going to get his left arm so that it is at his full extension forward. That really is it, and we're going to measure it from his underarm or his shoulder. Both of them are about the same. You see, there's his shoulder, there's his underarm. I'm going to take forward to the front end of his stroke, and we're getting 0.92 of a metre. We'll plug that into our figures, into our stroke length calculation. You see the forward reach is 0.92 of a metre. We're then going to take him forward, but we'll get rid of that picture first. I'm going to take him forward so we see the back end, his back extension, and again we're going to take him from his underarm or shoulder right to the back end. So we'll do the line tool again, we'll take him from his underarm and we'll go back to the furthest point of his hand. And that's 0.63, so we can plug that into our figure as well, 0.63, and we get a total extension of 1.55 metres. So his stroke length, that's the extension forward to extension backwards, is exactly 1.55 metres. We're now going to judge Adam's speed through the water. So we'll take a line tool and present it right at the front of his head, and we'll take it forward exactly 5 metres. I'm just going to adjust that because I think it's slightly off. We'll just pull that up. Didn't grab it. As you can see, oh come on, getting it to 5 metres exactly in a straight line. Okay, I'm just going to pull the label away and pull this just down a touch. There we go. So we know that's 5 metres. We're going to swim him forward after we've started a stopwatch. Now luckily Canovia has a stopwatch and it runs exactly to the frame rate, so it's going to be accurate from one point to another. So let's just start him, stop him, and just move him forward. And what I'm going to do is just turn the persistence of this on always so we get a nice. Now I can move him just forward one more there. So I think that is really when his head is absolutely at that 5 metre mark, and we've got 2.53 seconds. So now we can do the speed. So we're going 5 metres in 2.53 seconds, which means we've got 1.97 metres per second. That's exactly what we're doing. So we've taken Adam back to the beginning of that line because we want to count his strokes as he goes along. Now if we look, he's going to do 1, 2, 3, 4, and it's clearly going to be more than 4. let's just take him back. That's not the most extent. That's just about the full extent of his stroke in front of his hand, in front of his head. So what we're going to do is we're going to take a measurement of that, and we'll take it from his shoulder all the way to the front of his stroke, level, and we'll look at that measure is 0.77 meters. So we'll fill that in as 0.77. We're looking at his stroke length, remember. And now we'll get rid of that, and we'll take his stroke slightly too far. No, that was about right. So we're going to now take his measurement from his shoulder to the front of his stroke, but let's just do a check on that, because we can draw a straight line up from the front. If we get rid of that display measure, take that and put it right on that line, we get just more than that. Wrong one. Really is 0.3 that we've got to reduce off that. So we've got 0.77, that equals 0.77 minus 0.3, and that's the extent of the next stroke he's taken. So the strokes he's taken is 4.47. We know that the seconds he's taken is 2.53, and that gives us 1.76 strokes per minute. Now from that we can start working out his efficiency. We've got all the information we actually need. Adam's efficiency is effectively the increased or decreased distance that he moves relative to the amount his arm moves. If his arm moves 1 meter and he moves 2 meters through the water, then his efficiency is half. His arm movement is creating half the movement of his speed. So we need to know the meters per second his arms are moving, and that's a fairly simple calculation. All it is the meters his arms move in a stroke times the amount of strokes he's taking in a second, and that comes out to 2.73. Now the meters per second he's moving through the water is 1.97, so you can see those two are going to lead to an efficiency rating less than 1, 0.72 in fact. So we've got our first initial our initial efficiency rating for Adam is 0.72, and the idea is for us to increase that efficiency. Or, if we just want him to be fast, we can work with the strokes he takes per second, or the distance he covers per stroke. And that is effectively how we're going to work our model. The only difference is we have something to consider. We have his feet, his legs. And because this video has taken a little bit long to explain, I'm going to do that in another video next week.
So there we go. We have our first model of efficiency with Adam there, where I'd have assumed he actually was moving more than his arm extent was moving, but he's actually moving less, so his efficiency rating is less than 1. That's interesting. It'd be interesting to see how you stack up. You might have an efficiency rating of more than 1, but a very slow stroke rate. He had a high stroke rate. So things to play with. That's exactly what this is about. How can a coach help someone improve by making calculations that are meaningful? We're going to have to look at the legs next week because it took slightly long. But hopefully that set you thinking. See you next week. Keep well. Keep trying. Keep training.